All right, we're going to answer question 5 here. It says the Sunny Coast Cricket Club room is undergoing major work project. This project involves 9 activities, A to I. The table below shows the earliest start time in duration in months for each activity. The immediate predecessors is also shown. The duration of activity C is missing. And it's saying the information in the table above can be used to complete a directed network. This network will require a dummy edge. Then we have to complete a bunch of questions here. I'm going to begin by drawing out what my network is going to look like. So I'm going to grab a black pen and I'm going to begin drawing. First thing I'm going to take note of is that I'm going to start here. Then I is the only thing that doesn't appear as a predecessor. So that is going to be where I end. And then I'd also take note of the fact that I've got a B and a B here, which means I have a dummy edge from B to A. Okay, if you've got a spare piece of paper or some scrap, you'd probably want to use that. I'm just going to utilize this little bit of room that I have here. So things might get a little cramped. All right, let's give it a go. So we're starting here. And I've got A and B coming off it. I'm also going to write in the times of each. So the durations, that's 2 and that's 5. Immediately, actually, no, let's stop there for a second. I'll go C is coming off A and B. So actually, I am going to have to do this immediately. Draw my dummy edge from B to A. So here's my dummy edge from there to there. That's my dummy edge. And then off this now, I have C. Now, do I know the duration of C? I don't. But I can actually, let's leave it for now and we'll keep on going. I keep saying that, but it'll make more sense as we keep on going. So let's just leave C as having no duration for the time being. Then off D, I have C. So D is coming off C there. And then let's just put that straight as well. Again, do this in pencil. We might have to change some things. D has a duration of 7. Now, at this stage here, I think like we're going to do it because we know that, you know, they're following one from the other. So we're going from C to D, and I know that C has an earlier start time of 5. So if I was to just put this in, I know that the earliest start time of C is going to be 5. So that means the 5 is there. And then I know that the earliest start time of D is 7, which must mean that C has a duration of 2. That's the only way that that can work. So if we think it through like that, it's not too bad. Then we keep on going. So I've done A, B, C, D. Now we come to E. E is coming off C. So I'm going to do E coming off this way. And E has a duration of 9. Then I'm going to go F. F is coming off B. So I'll do it like this. And F has a duration of 3. Then I have G. G is coming off D. Where is D? Here it is. So this is G. And G has a duration of 4. And then I have H. H is coming off F. And as you can see, E, G, and H all have to join up. So if I was to do this a bit nicer, I should have planned this a bit better, but nevertheless, here we are. H is 9, and then E is there. E was 9, and then coming off all of these ones is I. And I has a duration of 2. Now that's pretty tricky to draw that. And now once you've drawn it, EGH, that all looks good, we can start answering some questions. Now some of this, we didn't have to draw all of this for us to kind of realize the first part here, which says complete the following sentence by filling in the boxes provided. This dummy activity could be drawn as a directed edge from the end of activity what to the start of activity what. Well, it's coming off the end of activity B, which you can see there, and it's going to the start of activity C. What is the duration of activity C? Well, we already figured that out. The duration of activity C will be 2. So just like that, we did not have to draw the entire thing to figure out A and B there. All right, but then the next one, it says name the 4 activities Name the 4 activities that have float time. All right, to figure out the ones that have float time, what I'm going to have to do here is do a forward and backward scan. So I'm going to grab my pen here and do a forward and backward scan. Now, I'm just going to fix this up a little bit because this is going to be 2 there, but then this will be 5. 5 becomes your earliest start time because that's 5 there. Then 5 plus 5 is 8. 8 plus 9 is going to be 17. 7 plus 7 will be 14. 7 plus 9 will be 16. 14 plus 4 will be 18. 18 is my biggest number. 18 plus 2 will be 20. This whole thing is going to take 20 minutes to complete. Then I need to do my backward scan. So I'm going to go 20. That's going to be 18. 18, 14. 18 minus 9. Oh, wait, have I messed this up? No, 18 minus 9 is 9. 18 minus 9 is 9. 9 minus 3 is going to be 6. Then I keep going back this way. 9, actually, let's do this. 14 minus, that's 7. Take the smaller one there. 7 minus 2 is 5. 5 minus 2 is 3. Then I'm going to go 5 minus 0 is 5. 5 is my smaller one, then 0 there. Oh boy. Then you can figure out your critical path here, which will be 0, 0, 5, 5, 7, 7, 14, 14. It'll be there. So those are all my ones. Name the 4 activities that have float time. So the ones that are going to have float time are going to be A, F, E, H. So just everything that isn't on your critical path. So A, E, F, H. So come here. A, E, F, H. Alrighties. D. The project is to be crashed by reducing the completion time of one activity only. What is the minimum time in months that the project can be completed in? So I'm going to crash this thing. So the project is going to be crashed by reducing the completion time of one activity. What is the minimum time in months that the project can be completed? So if I'm going to crash it, I can only crash one thing. It has to be something on my critical path. That is for sure. Immediately, I would want to just crash I. That'd be the easiest thing there to crash because I is by itself. I don't have to worry about anything else. I'm going to crash I. Just crash I. Because I just have to crash one activity. What is the minimum completion times a month that it would take to complete? It's be crashed. The project will be crashed by reducing the completion time of one activity only. What is the minimum time in months the project can be completed in? Well, the minimum. If I can crash one activity, it means I can take out all of that time, right? If I could take out all of I, that would only reduce it by 2, right? If I was to take out all of I, it would take it down to 18. If I could reduce B, I could only reduce B. I could reduce B by 3. So that's actually better. If I reduce B by 3, that would take me to 17. So that's if I reduce B. That's if I reduce I. Because remember, the reason why I know I can reduce it by 3 is because this is 2. So the flow time there is 3. So I can reduce it by that much. Here, this is 7 and 4. 7 plus 4 is 13. And this is 9, which gives me an overall float time of 4 there, doesn't it? 7 and 4 is 13, 9. If I crashed, I could crash either D or G. And we don't have to say which one it is, but if I did that, I could reduce it by 4, bringing me to 16. Would that work? No, it wouldn't. Because if I reduce that, say I got rid of, let's just say I got rid of all of this. Then that means I would end up going 5 plus 2 is 7. 5 plus 2 is 7. 7 plus 7 is 14. That would be 14. I would still end up with this 17 over there. Meaning I can't beat 17. 17 is the only thing I can get to? If I can only crash one of them, I can only get to 17. Okay, my answer is 17. That's tricky. That's just looking at it for a while and thinking about it. The minimum time I can crash this is 17. Is to 17. And what I would do is I would reduce B. I would reduce B by 3, making it 2. And that would be the best thing to do. And the reason why I would do that is because if I was to now think about it, it's also going to result in a reduction here. So a new critical path wouldn't be emerging. This would now become 15. Just so you can see it, this would become 15. And then I would end up with 2 plus 5. So I'd end up with this would become 2 there. Then that would become 2 plus 2 is 4. And then that would become 11. That would become 15. Yeah, perfect. 15 and 15 there. See that? That's spot on. And then it doesn't matter here because this would end up being 4 plus 9, which is 13, but that's fine. Yep, reduce B by 3. Reduce B by 3. Now, I don't have to say that. What is the minimum time in months of the project? I just write 17. I don't give them more information. We'll look at the study design thing, the examiner's report, to see what they say. All right, for the first one, let's just start with 5A. 5A, B and C. B and C, 26% of people got that right. Next one, 5B. Answers 2, we got that. 50% or 49% of people got that right. Question C. Only 23% of people got this right. A, E, F, H, we got it. And then question 5D. The answer is 17. And as you can see here, reduce on the critical path. 20, yeah, good. Reduce B by 3, that's what we said. And that will be the same as B, F, H, I. And that's what we said as well, because then it will be B, F, H, I, same thing. Yep. Tricky questions. This actually isn't that bad because you're only reducing one activity. If they asked us to reduce more than one, then it gets real squirrely real quick. Networks is tricky, people. Hopefully this little video helped in helping you. I'll see you later.